Welcome to the Dobsonian Power Night Sessions. This is the 8-inch Dobsonian that is outside over an equatorial platform to track the sky. It's a bit windy, less than yesterday, but I didn't want to risk to place the king outside, and I wanted to stress test also the 8-inch with a new position that I have. I had to rearrange everything here. The telescopes from now are working in a different position, which is more protected from the wind and also from the LED lights. The LED lights that 25 more or less, they cover all my west side, so it makes a bit more of glow, but I think we will be fine as long as we can use the filters and everything. So the filter that is inside is a softer one. I want to test it with a soft filter, the Baader Neodymium, to see if I still can use the Baader Neodymium and don't have to upgrade to a hard broadband or a most powerful broadband filter like the L Pro. It's a bit more powerful, it cuts more light. I want to avoid that. And also not only the light it cuts, and because of that, actually, it gives a tint of the images on the screen which is more orangish. So it cuts a bit of the blue that this filter, the Baader Neodymium, has. And I like to preserve the most colors I can. One thing that you were asking in the community, one of you in Discord. By the way, join us on Discord. I can't place the messages here because it's not working also. Yeah. Can you listen the message from Discord? My voice. You didn't listen this? Join us on Discord, no? You didn't listen the join us on Discord, by the way. I think it has the... Nope, yes. It's another problem. It's another route. I have to figure it out. Okay. You were asking on Discord, one of you, about the... yeah, I will not use it. But you listen the beep. Tell me that you listen because it's to cover my bad words. This. Do you listen the beep? Beep. Yes. What a weird thing. I have to check it out. And you can hear my voice distorted. It's weird. You were asking about the mono cameras. Yeah. The mono cameras, and you know what? I prefer the cameras with color because I like the colors, everything. But since for a while, I was thinking about the mono cameras. Well, actually, in the Venus elongation, we were capturing Venus. And Venus with the mono camera will be much better because the mono cameras, black and white, they capture more detail. The same camera, the 294 color and the 294, for instance, it's the same camera. But in black or white, black and white, it will capture more detail. It works better. So in the astrophotography, you use 3 filters, the red, the green and the blue, and you have to, it's a cumbersome. You have to take you triple the cumbersome of capturing. Well, at least for me. And then you join the channels, the color channels, and you get the color in the picture. So it takes more time. But it gets more detail like that also. But you know what? I was thinking, and maybe I wouldn't mind to have a mono camera to watch, well, but as an additional camera. To watch, for instance, the galaxies, most of them don't have color. I think it was Samir one of these days, he talked about that, the mono camera. And to watch like galaxies some galaxies, or most of them, you will see them as we see with our eyes, without color. It's a different thing that it probably will be fun to and interesting to have if one day I have one. And also the planet Venus, because it has no color in the image. Those colors that you see are false colors, the purple, everything. And more pixels for black and white. Yes, rather than splitting out a percentage of pixels for RGB. Yes, it's that. Because for RGB, it's 1 pixel extra that it's randomly distributed or attributed, no? It's weird. I understand the concept. They come with a bunch of pixels and they fill the pixel, no? The photons fill the pixel, but one of them will be randomly chosen by the camera if it's green or red or blue. Something like that, no? If SharpCap could add the filters real time, will be awesome. I think I saw somebody recently asking that to Robin. Yes, it was yesterday, it was very recently. And about that, but using live stacking, during live stacking, to change the filters, using mono camera, black and white, and then change the filters because you have to change, for the people that don't know. One in red, another in green, and so on. And he answered that it will not be possible. It's not in his plans. And but by the way, talking about SharpCap, I not immediately, but yesterday after the stream, I reported to Robin that that it was working, the push 2. And as I said to them and to you, he explained that thing of the sigma. The sigma. You have to lower the sigma because you are using 200 sigma. Well, Robin, but in the configuration, I'm using that configuration since the beginning. It was the configuration that worked for me. Oh, you should use between 30 and 50. But I used 200 and recommend on my videos to use that feature. Sigma. It says Sigma. I don't know what is it. Sigma. And I trial and error. I placed 200 and played solved fine. From there, or since then, I'm using always 200 at Sigma, whatever it is, and it worked fine. So the problem was not that. It was the clouds. The problem that night was the clouds. That was not plate solving. Because yesterday was plate solving. And I said to him yesterday, look, I'm very happy, it worked fine, but the sigma was the same. And he explained what was the sigma. I can show you. I can tell you. It's better. It's faster. It's a summer... Well, we are always learning. It's very simple, but we go to the forums. Let me see my messages. Yes, here. So he said, the sigma setting is one that comes from ANSSVR. It's the software plate solving. The plate solver software that I use. And it is a measure of how strong the signal of the star needs to be for the star to be allowed. Sigma equals 50, it's lower than mine, means that the star must be at least 50 times as bright as the noise level of the image, and sigma 200, it's mine, it's for Robin it's too much, means 200 times as bright, etc. If you setting it too low, will lead to noise being detected as stars. So if we set that sigma too low, the noise will be mixed and be confused by the software and be detected as a star. Too high means only the brightest stars will be detected, which might cause issues if there are not enough of them. So this is the explanation. I use it too high according to Robin. So it was supposed to detect only the brightest stars in the field when we are live stacking, as we will be doing now. But it works, I don't know. And I will not touch it. It's working. Thanks, Abiosis. Hey, Nathan. Look, Nathan. Where is it? The Star Sense 8-inch Dob, it's a good Dobsonian telescope. I say it's a good, in my opinion, because it's a Dobsonian telescope and it's 8-inch. The fact that it has that push 2 might be an advantage for people in light pollution environments or heavy light pollution, because it will help you to find the objects. In my Bortle 5, now Bortle 5-6, even like that, with all the LEDs that I have now, I can use the Telrad and it's much easier. Joaquin, thank you very much for gifting 5 Dobsonian Power memberships. Thank you. So, Obscurity 89, Robin Caliente, and YouTube didn't say more because this is random. You are now members of the Dobsonian Power channel. Don't forget, the new members, to go. You now have access to the community members tab, where you can access to my previous videos just for members and polls, and you can participate now in the new name that we will give a new name to the 8-inch. The telescope, it's outside. We have the King already, it's the 12-inch, and we have these graphics for the King. The King. And now we will choose the name for the 8-inch, and then I will do the graphics also for the 8-inch. So people is giving opinions about names, one name only, with one word only. It's easier for me to talk about it here on the live stream. And you can access that also. And if you join us on Discord, you can post links on Discord. So don't forget that. Now let's... so the Sharp Cap thing, it was interesting. I'm very happy. Let's open Sharp Cap, because I think the Crescent now it's in a better position. I will go to the Crescent Nebula, because yesterday we couldn't because of the wind, but now with the 8-inch and a bit less of wind, I think we will be fine. So first I will connect. I have to focus. I have to focus because this was with a 12-inch yesterday. I will focus and I will connect the platform. No, don't place the name here. I will pick the name from the community tab. Only the members. You are a member. Yeah, the donuts. The famous donuts. I will stretch this to have a better... Look, I'm taking the opportunity of the weather. The sky is clear. Well, not so clear. It has a bit of haze, but it's fine. But I'm taking the opportunity before the moon comes, and... the brightest moon, and the bad weather or something. We should take the chance while we can. I will focus the telescope first to a brighter star.
start hopping.
I think it's fine. You see, I do the manual focus here. And what's happened? Ah, the music. I have to place this in loop. I forgot. I do it manually with the 8-inch. Although with the 12-inch and the refractor, now I have an autofocuser there in the refractor also. But with the 8-inch it's so simple, and it's the I don't know, it's my beginner telescope, my beginner setup. It's very, very simple, and it's so easy. You see, you saw how I focused it fast. Now it's a bit grainy. I don't know if it's the weather, but or the lights. I don't know yet. Now this is the star that is on Cygnus. So to the right will be the Crescent Nebula. Well, this part of the sky, it's over the town here, the city that I have near me. Yes, the music was off because of the lack of the loop. I have to, this way I have to have it on loop. Well, I usually also always have it on loop. Looping. Yes, it's focused. And now I will point to the, I will use the push tool. I will use the push tool. Let's see the push tool. So, Nathan, the star sense, remember that, just to close that that matter. Remember that the push tool, I can't use it like this with this. Remember to, with the push tool, will not track the sky. What you are watching here is a star that's not moving because the telescope is over an equatorial platform. So it tracks the sky. I place the Dobsonian. If you have an equatorial platform, you can place the star sense over it. But the push tool that has the star sense, it's only to find the object. Then it will run away from the eyepiece or camera. It will not track. The go-to system is the system that tracks the sky, which I strongly recommend if you have the money, the additional money, because later you will find it a need. Even more comfortable to observe visually, because it's tracking and you just have to watch. And it's a myth that with the go-to you don't learn the sky. That's a myth. You don't learn the sky if you don't want to learn the sky. If you have other priorities. If you want to learn the sky, you learn the sky even without a telescope. It's how I learn the sky. Even without a telescope. You sit there looking at the sky with an application to check the constellations that you are watching. Look at this star. This star is this one. And this is the constellation. Oh, I'm watching the constellation. If you don't have heavy light pollution. If you have, you will learn it anyways. So now what I'm going to do is to point to the... Let me just place this here with the 8-inch. No, it's Sadr. S-A-D-R. It's the central star of Cygnus constellation. Now I'll use the push tool. You see, I'm here watching the wind and the movements. I like to have a feeling how it's going to be. It's windy, but not so much as yesterday. Well, the difference is not too much. Okay, push to assistant. And we will now click here on the search and Crescent. And start. Let's see if it works. It's plate solving. And it's not solving tonight. I can find it easily visually, but I want to try. Congratulations, Marco. Everyone deserves clear skies. It's not solving. Now it's not working. Cancel. Let me see that Sigma stuff. At the end, Robin is right, and so we'll be at plate solving. Plate solving Sigma. I will lower from 200 to 100 to see if it's that. He advised to use 30 to 50, but now plate solve again. Push 2. Yes, okay. Crescent. No, I don't have to have Stellarium. Let's see if that's the problem. Well, it's a bit windy. It's the same. It's not solving. When it takes too much time, close, cancel. Let me do another test. I will do the 50. Sigma 50. I think it's not that. But H2. Crescent. This is very easy to use. Can be the wind. Now the wind is strong. Even with the 8-inch. I'm using the 8-inch without any light shield. I can't place a light shield, otherwise it will be even worse. Start. Can be sensitive to the wind also. It's the same. Yes, thanks Mark Parkinson. Give a like to this live stream to boost it, to reach more people. No, it's not working. It's not the Sigma. I used the Sigma 200 and it always worked. I'll place 200 again. It's not this. Apply, okay. So what can it be? The gain? Start. No, it's not solving. Yeah, thanks. Uncle. Because Twitch is a different platform. It's focused on gaming and... No, it's not working. It's not a game. Let me try the old-fashioned way, see if it works. I mean, that with Stellarium. Let me open Stellarium, see what happens. I will try the old-fashioned way. Star Hope! Oh, I wanted the things to always work fine, but they don't. Cygnus, Crescent Nebula, connect the telescope, Ascom, connected, control 1, should go there, the telescope, here he goes. Here it is. Now what I usually do is a plate solve. Plate solve. And usually worked. It can be the wind. Or maybe because it's a bright star messing with the object. I will move it a bit. Let's see if it's the star. It's the same. The old method, it's the same. I will close it. So the problem is not that. Let's use the push to assistant now to see what happens. Crescent. C27. It's weird. Because yesterday it was working so fine. Could be the wind. Okay, I will do it the old-fashioned way. Tonight is everything back to the origins. Everything manual. We can't rely on technology. I was so happy with this, and tonight it's not working. But yesterday it worked so fine. Well, I will close. And I will do it the old-fashioned way. Let me see the Telrad, how I going to place the Telrad. Yes, I'm good star hoping. I'm good star hoping. In these conditions, if I was on Mortal 9, it will be harder. But since the beginning, I remember when I first started using the Telrad and finding the objects, different deep sky objects, I was good doing that. I learned fast. I like the patterns. Okay, it's easy. This star, now I can't see. I usually saw that those stars, all the stars of Cygnus, the cross, but now it's hard to see this one at the right. To make that... okay, I will do it. I don't need this anymore. I don't need your software. Hold on. The wind is coming from the north. See, it's there. Yeah, I'm good star hoping. It's an advantage. Thank you, Mark Parkinson, for being a member for 3 months. Thank you very much for your kindly support. Okay, now we will try to live stack 4 seconds because this is super. I'm using the Nexus. The stars on the Nexus, which the 4 seconds will be more than 4 seconds at reality. It's the beauty of the Nexus. Stars are good. Bam bam. Not bad. We see the gradient. And sharp mask. Not bad, 8 inch. 8 inch. 8 inch. 4 second exposures. Gain 350. You see, well, this area of the sky, it's harder because there's many stars, many stuff here. But we see more noise. I can see the difference from now and before having the LEDs, the light LEDs. You see the color. The color here, this color noise reduction strength. This is a new feature. It helps. It helps a bit. Yeah, not bad. This is turning me a bit happier dealing with this new circumstance of having a bunch of LEDs here behind my house. That means that it is possible. Well, I know that it is possible to work with light pollution. Many of you have more light pollution than me. But the thing is, when you get used to go to drive a car, if you suddenly don't have the money for the car and have to go by bus, you will feel the difference, you know. It's kind of that feeling. Now let's adjust the colors to green, lower the green a bit. It's more noisy, clearly. Now I can change to the different filter, to the Quadband filter, which is good for this nebula, to see the difference in this nebula. Let's stack a bit. Well, it's more or less polar aligned, it's fine. Maybe the speed, okay. Antonio Cortez is in a house. Not bad for an 8-inch Dobsonian, and I don't know if I still Portal 5 or 6 now. I'm trying to figure it out. By the way, for the ones that don't know, we are streaming from the south of Europe, a beautiful region called Algarve. Planet Earth, continent Europe, country Portugal, region Algarve, 37 latitude, Portal 5. Portal 5? I may have to change that. I don't know. So far I think I'm still on Portal 5. Because if we watch the images, you know those images with the Portal scale? What happened with the music? It's a connection. Let's see if I have the image here. If you search on Google Portal scale, it will retrieve different images. But all of them, they are not equal. They are not equal. Let me see one that I like. That match the reality. Yeah, maybe this one. I will download it to show you. The Portal scale. Oh, this opens with an old software also. Okay, Portal 4, Portal 5. This match the reality. I can still see the Milky Way, but now I can see more towards the left, towards the Portal 6. So this is Portal 5 here. You see, if you are on Portal 5, you see like this. It matches the reality. Portal 5. Portal 6. Portal 6. Portal 7. And Portal 9. 8, 9. It matches the reality, no? Super white, the 8-9. It's inner city sky. Here, Portal 7. It's city / suburbia transition. Portal 6, a bit better. Bright suburban sky. I don't have it like I'm on. I can classify this as a suburban area, but it's country. It's not so heavy. I'm on Portal 5 here, it's suburban sky. And here suburban to rural transition, which is Portal 4. You can start seeing details on the Milky Way. I once was here, between 4 and 5. Now I am here. I once was here. I could watch some details. Then Portal 3. Look at the details you can see of the Milky Way. Here, Portal 2, amazing. And Portal 1, at the right. Excellent dark sky sight. Usually, if we go to a darker site, a rural site, will be like this, Portal 3, most part of the cases. And it's good enough. So you see, with a star sense, you do nothing here. Without a push to, with a Telrad and a finder, you can't do nothing here. However, I think in Portal 6, 7, okay, 7 you can. But at 8, 9, you see, I'll watch it. But at 7 you can. Because you can see the brightest stars. You will have more trouble to find them. Because you will miss some of the stars. But at the end you will get it. So let's see how the Crescent is with the Baader Neodymium filter. It's doing fine. 124 stacked, only 12 ignored. You see the difference to the 12-inch? It handles better the wind. Although it's less wind now than yesterday. 8 minutes and 30 seconds. Yeah, that's a shame, Antonio Cortes. Oh, what a shame. I know your feeling. It's horrible, and in my situation that I had those LED lights, all of those LED lights. It's like a glow behind my house, but the thing is, I know that it's a frustration, but I know that I can't do nothing about it. I can't do nothing about it. They were needed. The lights were always there, but they were deactivated for stupid institutional relations. But they are in an important place that needs some light to avoid accidents, traffic accidents. So it's impossible, and they are strong and high LED lights. But your situation with the neighbors, it can be even more frustrating, because you know that with a bit of just a bit of good willing from them, everything will be much better. I hate neighbors. That's why I don't have neighbors. Well, I have, but we are all with a certain distance. That's fine. I'm sorry to hear that, Antonio. By the way, did you receive already the Nexus? Did you solve that thing with the dew in the Nexus, that problem? Tell me. Or are you still waiting? No. Impossible, the Milky Way. I can see the Milky Way here, and I'm on Portal 5. No. I can see the Milky Way. I can distinguish perfectly. I can't see anymore some details of that part that has more details, the core, in the direction of Sagittarius, but I can see perfectly the Milky Way. What I miss now, since the LED lights, is the part that is more faint, it's less visible, because the Milky Way does like this here, an arc. And I can see the core here, Sagittarius, to south. But the other side of the arc, I miss that the rest of the arc. I can't see now the full arc. And in the past I could see much more of that arc. Portal 5. No, Portal 4 you can see perfectly. Oh, the airport. Okay. I'm glad you did it. And it's working fine now. Yes, we never know. And the more you have, the chances are higher that you can have bad luck. Well, I can see that it's not so bad polar aligned now. My platform, it was a work that I was doing these days. Now let me adjust this to save as scene. Not bad. Stable, much more stable also. And the color. Less blue. Okay. This is the natural color. Not bad for an 8-inch. This noise I will clean with neat image easily. And we will have these details. Stars are fine. It's focused because the spikes of the stars are not separated. They are only 4. Save a scene with 30 minutes only. Now what I'm going to do now is, because I have the filter drawer, what I have is another drawer here inside. This was broke by the delivery guy. He threw the air shell wedge with this and the drawer, everything, bam, to my backyard. But fortunately nothing happened, but this box. It was well protected by AstroArt Finland, our sponsor. And here I have the other filter, the Quadband, like this, ready to go. You see? Ready to go. I just need to place it, take the other and place this one like this. It has magnets, so it will be fine. Let me just check and clean. So I just changed without having to unscrew everything. Hopefully I can do it. It's the test I will do. I can change the filters without losing the nebula from the field of view. Hopefully. We'll see. And we'll see the difference using a narrowband filter from Altair. So let me go outside and change it. First I will reset this so I can see the nebula. Okay. Let me stretch. Okay, I can see, barely can see. Ah, the focus change. You see, now we are working at narrowband. We have to refocus. I forgot that. We have to refocus this because the focus changed with these filters. Hold on. I think it is focused. You will see the difference. I think it is focused. You lose more stars from the field. Let's stack it to see what happens. Interesting. Yes, I refocus it. Some filters are parfocal, but these are different. And this is a narrow band. Look, first difference, the histogram. Okay, the noise is the same. The noise is the same. The histogram shift a bit to the left. Remember, we are cutting more light. But the bands, the wave bands of this hydrogen will pass. Lower the green. Now what we will need is more time. This can be, this kind of gradient at the borders can be because I forgot and I'm using the flats from the 12-inch. So it's okay. Doesn't matter. We just want this. So you see, the first difference is the background is darker, less stars, and the image starts more faint than with the Baader Neodymium. It will require more exposition time here, more stacking, to reach to a good point in the screen, but that's expected. Although it's supposed to get more details after a while. We'll see. I think it is focused. Yes, it is, because I can see the spikes here. We lose a bit of the spikes also, at least for now. Oh, you didn't use it yet. Yes, of course, with the weather. They don't cooperate. It's a shame. Thanks, Christoph. It's a shame that people can't be... That's why I hate to have many neighbors and... I prefer to live surrounded by bugs and insects and animals. Because of the human behavior is... And it's worse now, it's weird. People are more selfish now. Much more selfish. It's rejecting more frames, but I think it's because of the wind. It's super windy now. I think it's like yesterday. The wind starts to blow more at the middle of the live stream. Until it messes it all. But I will keep the filters like this. You see, only 2 minutes right now. Because I don't want to mess the image with elongation, with elongated stars and so on. Yeah, sometimes it's not just to be rude. It's sometimes there are people that are very, or that look very kind, and you think, very nice people, very with education, but at your back they hit you. They are fake. So sometimes rude people understand better. They are rude. But if you know how to talk with them and make them understand your needs, they are kind at the heart. I prefer those people rather than people that looks very polite and very kind, but at the end they are so fake that they trick you. You don't know what to expect. And sometimes some neighbors can act like that. Now it's stacking fine. Stabilizing the wind for sure. I noticed that now that the stars are getting at the 4. But they are a bit more larger, the stars, because they are at on average at above 5, the measure here in the filter. And with the other filter, they were below 4, but now they are 4. Yes, it's the wind. It's the wind for sure. Because it's focused. And we have to wait more. Yeah, this is the effects of the flats. This gradient are the flats that were not supposed to be here. But we don't mind because we want the core of the image only to be scene. Let me see the enhancement. Cuts light. This noise reduction I don't like very much. Prefer like this. Now, one thing that I think I'm noticing is more details starting to pop at the hard region, which is the middle of the nebula. The Crescent Nebula, usually we can see this like a C letter, no? But the hard part is to capture the details here, the rest of the nebula. Live stacking. You can see perfectly the central star. Well, this is a soft narrow band, so it's not supposed to cut too much light as the others. It cuts, but it leaves 4 bands. Let me play with the enhancements. Yeah, we need more stack to clean the noise while we are watching. Yeah, some people are just miserable. They are an idiot. Now let me pull the other image without processing it, because we want to check this without any manipulation to understand what's happening here. Okay, this was with 200 frames. And this is ours now is with only 100. Yeah, this is the effect of the flats for sure. I should have removed the flats. Let me see if the gradient can help. Oh, I have to reset, I think. Yes, these effects of the flats. But I think the gradient did worse. It's doing worse, I will take it off. If I take the flats, it's too late to do that. It's too late. I messed already. Yeah, I messed the image already. I will reset without the flats. Thank you, Joaquin. Have a nice week. Or rest of it. So noisy. I guess I have to deal with the noise. Well, I didn't try yet another thing. It's the stretch here, the stretch mode. Yeah, I can lower it. Now, while this stack, I want to show you something very, very interesting. Let's see if this works. Because tonight... Yeah, it's working. So this will be the tonight breaking news.
Breaking news.
The ones that were here yesterday, which I appreciate your loyalty, had the opportunity to watch an image from James Webb Telescope. It was 2 days ago. An image with deep sky image with new one, full of galaxies, right? Now let's level up. Because the image is not only we were watching the image, how beautiful it is, look at these galaxies, but now let's understand what's behind that image, which is very important. Now, the articles from the scientists are a bit of cumbersome to read. People don't have the time to read them. They are not used to attract the mainstream, and so it's easy to just don't have the knowledge and be aware of them. So I decided to summarize for you and to give you an interesting information which I learned, and I want to pass that knowledge, which I think is important and interesting, to you. So you can see the top of the news, it's not an attractive title. This is the image I will skip. Now, this image that we saw yesterday has one important, very important object here that I didn't know. Let me go to the center of the image. It's right on the center of the image. You can see here, you see stars. Let me do like this. Here you see stars, you see with the spikes, they are kind of bluish. You see the stars. Here at the left also the stars. And look at this one. This one. Where is it? Here. Right at the middle of this picture from James Webb Space Telescope. This pinkish object, it's not a star, it's a quasar. And this quasar is so important in this image that you will see now. That was the object that gave us all the knowledge that we didn't know, but now we know, thanks to this image with this quasar here. The most powerful quasar known at this distance in time, because this was taken at the beginning, after the Big Bang, just about, I think it was 900 million years, so it was very close to the Big Bang. And this was the image that different institutions, not only NASA, but also cooperating with using not only the James Webb, this James Webb was essential, but also other telescopes in Chile, from ESA, from different institutions, together, working with other images, allow us to discover something. I will summarize it for you, because you will not read all of this mess. So, The thing is, 1 billion years after the Big Bang, the gas between the stars and the galaxies was opaque, but then became completely transparent. Okay? This is the starting point. The gas was opaque. You know, there was a period after the Big Bang which we can't see because it was opaque, but suddenly it became transparent. And we didn't know why until now. And look what they discovered, these guys. Okay, this was stars forming and galaxies assemble. Look at these dots. Represent the stars formation and galaxies assemble. This was at the reionization phase of after the Big Bang. So the galaxies, what happened? Each little bubble here has a galaxy inside. So the galaxies began to change the gas around them. This is the gas, these bubbles are the gas around the galaxies at that time. Then they start to transform. You see at this picture here. The areas of transformed gas expand, they expanded, and then suddenly they clear, and the galaxies were separated. It's the end of the reionization. Or reionization. It's reionization because they ionized and then they stopped and then they start again doing that process until they get cleared. Okay? More than 13 billion years ago, it was the era of reionization. Okay? The universe was a very different place. And this phenomena happened. Now, they pointed to this quasar intentionally. Because pointing to this quasar at the center, this one, this pink quasar, this is a quasar, it has a huge black hole, and it was intentional. And you ask me, why, Tiago? Because pointing to this bright, super bright quasar allowed these scientists with the James Webb and other telescopes on Earth to distinguish within the light of the quasar the gas which has popped because of the light. And watching that gas, they could analyze all of this and have evidence. This is a study that is not a proposition or an hypothesis or something or theory. They got evidence, which is things that I like in science news. So the process was here, and look at the galaxies they analyze. These are the second most important objects from this image. I don't know in this image, I don't know which are those galaxies, but they went deeper on these galaxies here, you see, to watch the transformation. This is very, very deep. This is in the early universe. All these galaxies that you are watching here were in the earlier universe. They are more chaotic, they say. They are more chaotic than those in the nearby universe. James Webb shows they were actively forming stars and must have been shooting off many supernovae. It was a young phase of those. galaxies. It was only these galaxies that you are watching here, and this is amazing, was when the universe has only 900 million years old. Okay? They did this on purpose to point to the quasar, and they were intentional, pointing to the point of time which the universe was between the opaque time and the transparent time. They pointed to the middle, so they can figure out these kind of transformations. Very interesting. Often people don't know this. Well, this is a recent information. 2 days ago. This was 2 days ago, released with different papers, which are here in the article, which I will not go deep on that. Now, they said they will soon dive into research about galaxies in 5 additional fields. So that means that this study was it was the results of this exceeded. These results exceeded their expectations. So they will do now in 5 additional fields, anchored by a central quasar. The technique will be the same. The quasar, the light, to analyze the gas. It's one of the purposes of the James Webb. So they will identify more galaxies during that era of reionization. Reionization. So the different telescopes they used on Earth also. And that's it. Until now, researchers didn't have this definitive evidence of what caused reionization. I have to translate this to spell it well. So this is completely new. Reionization. Until now, researchers didn't have this definitive evidence, this is important, of what caused the reionization. Before James Webb, they weren't certain precisely what was responsible. So this allowed us, this was 2 days ago, allowed us to start understanding much more of what happened in that beginning of the universe. This is very, very important. And I hope you enjoy this kind of information. That was the breaking news. Let's come back to our reionization of the Crescent Nebula. Let's see, 8 minutes. Well, it's more or less where it was. I don't know, I see more noise. It seems noisier. Let me save this. Now previously, if we save at the same number of frames, it will overwrite the image. No, the quasar is not responsible for the galaxy's formation. The quasar is responsible for is a technique they used to watch the gas between with the light of the quasar, those photons pointed showed the gas, so they could analyze that gas and that transformations and discover that. The quasar has only that purpose. It's like a light for you to watch. The responsibility is it's a process. It's a ionization. They ionize, they expand, like we saw in the image, and then they clean because that gas disappear. So become transparent. From then, or since then, the universe became transparent. And they are analyzing how that happened, how the universe was so opaque. How do we say this? Opaque. How the universe was so opaque? Because the universe was, that's why we can't go deeper, because it was opaque. We can't see too many stuff and gas. But that era of ionization was the transition to the transparent universe. Since then it was transparent and we can see. They went deep in that point of the time where the universe was not too opaque but not too transparent. It was at the middle, to study that transformation, and they discover it right now. What causes that transformation? And it was that process of ionization in the galaxies. The gas, and then the gas dissipate. Something like that. I don't know the details, scientific details, but we just like to understand something about where we came from or what we are. We are the universe, I don't know. You see, Quasar? I'm not talking about you, of course, it's the quasar. Most of quasars only in early universe, very big galaxies, Rao. Very. Versus. I don't understand. Let's see the picture here. How it goes. I don't know. Let me compare with... I was saying that in the previous version of SharpCap, if you save as scene, if you had an image with the same number of stacking, for instance, now I have 158 stacked. If I have an image from the previous nebula, it will overwrite without knowing. Now it asks if you want to overwrite or not, which is important. Because I lost loads of pictures because of that. Where's the galaxy? Gone. It was another object over it. So let's compare it. But we have less frames. We have less frames. I don't know why I see more noise with the narrow band. Why is that? This was the right one. At the right is the one with the Baader Neodymium, which I prefer. Yes, I can see a bit more of detail if we are picky. And this has less. This has half of the exposure of the one off the right, and it's supposed to have to double the exposure because it needs more exposure time. That's why narrow band is a bit... I think this will be... I have to try this with the moon. At the end, the Baader Neodymium does a great job. It was spot on, this filter, the Baader Neodymium. Strongly recommended. And the color is not so orangish. Most of quasars reionization because of powerful ultraviolet radiation from early stars and galaxies. Ah, yes. Yes, it's what happened. It's the ionization that we see, for instance, that nebula that we were watching the other day, the Iris Nebula. Watching the sky and learn about it is fantastic. Of course, this is not. This is at least I like to learn a bit, not to go deep on scientific formulas and stuff like that, because I'm not a scientist. But I think everybody should, that loves astronomy at least, should know at least the basics. And these kind of discoveries are very, very, very important for humanity, humankind. Yes, the right one is... But we have to wait, because with a narrowband filter, we need more exposure times. We need more exposure times with a narrowband filter. We can't expect, because we are cutting much more light. What I didn't know, and I don't understand, is why this filter, the Baader Neodymium, has a better background, a darker background than the narrowband. It was supposed to be the opposite, no? I don't understand. Maybe because I stretched too much. Maybe because of this. Yes, we need more time. Yes, I think we are getting a bit more detail here. But for my style, the Baader Neodymium, it's much easier. Let me see right now. Now we have 198 stacked. Almost the same. Let me see now. The difference. Now it's different. The left one is the narrowband filter, the Quadband, and the right one is the Baader Neodymium. I see. I start seeing more details. Look at here. Look at this part of the nebula here. Yeah. It's enhanced. It's enhanced. You see? It's difficult on YouTube to watch details, but now it's like a race. This one at the left, I think now catch it or caught the one at the right with a Baader Neodymium. But it needs more time. It's supposed, this filter, the examples, because when we buy a filter we should watch the results online. There are always results from people. For instance, I think I'm going to I think the Optolong L Pro could be a good filter for me. Watch examples online, watch the telescopes they use, and watch the Bortal sky, very important, they have the light pollution level, and compare with yours. And then you will see the results of similar setups, and you can decide better. This filter, the Quadband filter from Altair, it cuts loads of light. Look, the only light that it let pass, it's only these two bars here, or lines, that you see here, these wave bands. All the rest that you see here, all the rest is black. It's cutting. The filter cuts, it blocks. Notch, no? It's the term. And I saw results with this filter, but the results start appearing after 1 hour. The good results, 1 hour live stacking or 90 minutes. are the best. The difference between half an hour, 1 hour, and 90 minutes live stacking is huge. It is recommended to use flats to match the filters. That's the way it works best with my gear, yeah. I will have to test it because the flats work well in the 12-inch. The flats I took. And then I have a problem that people have to think. If you have a setup like mine with an equatorial platform, you have a threshold of time. You can't be all the night live stacking. Let me see if it's still stacking. It's still working, but in a while it will stop because it has 1 hour more or less the platform working, so I can't go to the 90 minutes, for instance. Quasars were more likely to be active when the universe was young and fuel for their accretion disk was more available. Quasar activity can be re-triggered by a collision between two galaxies. I love this phenomena. And the things they are discovering, we know just a few things. We have to know so many things yet. Yes, I will try to live stream so we can have a real time. I will place my all-sky camera outside the 224 and we can watch it together. I think it stopped the platform. When it's no, it still have it still has green. Yeah, definitely the details are there. Well, the flats. This now it's not bad. If we cut a bit here, let's see. We can use the same color noise reduction strength. It will cut a bit here of this color. We used in the other picture, but clearly we can see that the more we stack, the more, look at the core, we start seeing more and more slowly this forming, well, forming in the image because they are there already. Well, they were. Let me see how much time. Crescent Nebula. Oh, 5,000 light years only. It's near Earth. 5,000 light years. Well, Steven, we never know. We never know what happened. I think we will never know what happened to us if we really, when we pass away. If we transform in anything or something or nothing. I think it was supposed to be like that. Can you imagine if we all knew that, okay, when we pass away we go to a better place or a different place that is not so bad. We won't value life as is. We won't value. We don't care. We go to a better place. So I think the universe is so perfect that all fit together in a way that humans can't mess it all. We can try, but we can't. At the end, it's so powerful, and we are so... We are a subatomic particle to the universe. Less than that. Waiting a bit more, 70 minutes. Watching what happens. Let me see the other picture now. It was... I will have to name it. Was not this one. Yes, it was this one. I will write here. Baader. Oh, Neodymium. Neodymium. So I can distinguish. Let's compare the detail from the real time image. Neodymium. First, the thing that all filters over the Baader Neodymium. This doesn't happen with the infrared and ultraviolet cut filters, neither with the Baader Neodymium. That's why I like that filter. They are soft enough to allow the color to be with a more natural tint. I know we can process and change all the colors that we want at the end, but that's not the point here. The point is to watch in real time. Every filter below that I know, above the Baader Neodymium, I mean that cuts more light than the Baader Neodymium, gets this orange tint. Some more than the others. But in fact, this quadband filter can get a bit more of detail of the nebula if we stack. Now, from now, everything that we are stacking is more than we stacked here. More time, so it's not fair. But I can see that this can be a useful filter, the narrowband, for the moonlight nights. That will be an interesting experience. We become stars. Yes, we might become what we were. At the end, it's a cycle. And did you notice that the image... I like to... I noticed those details. I can't avoid it. Did you notice that the image that I showed, that they show here, of the galaxies formation, these bubbles here, they look like subatomic particles, but they are the opposite. They are so huge. This area, I will teach you one thing that I forgot. The area that you see here, the area that this bubble, the edge of the bubble, inside the bubble it's a galaxy, inside each bubble. This edge of each bubble has the distance to the core, to the galaxy, from the edge to the galaxy, is the same distance than the Andromeda galaxy to the Milky Way. The same distance, more or less. They tell that in the papers I saw, but I forgot to say. So we are watching here a huge distance. The Andromeda is what, 2500 light years. This is a huge distance, but at the same time they look like subatomic particles. Quantum physics. This is amazing. to watch the universe and think in the universe from these different scales, and you at the end you see the same stuff. It's incredible. I think the platform kicked me off. Yes. Okay. Save. And stop the platform right now. I disconnected the USB and this gave an error. I forgot to test the push to system again. Well, so I have some conclusions here. I'm sure that post-processing it will be 2.5 million light years. Yes, 2.5, 2500. Howdy, howdy, that one guy Roy is in the house. So we are Stardust, and you and me can still dream and imagine, let the imagination flow about what we will become after experience our lives here with good people like you and some idiots that are like you, of course. The idiots like the ones, the neighbors of Antonio Cortes that blow the pleasure of sky observation. We really need to evolve and to start thinking in not only in stupid things, but in a higher level. To help us in astronomy also. I hope we get that way while we are alive. Thank you very much for being here. It's very nice to be with you. I will keep streaming while the sky is clear, and I'll see you next time. Thank you. Bye bye.